Hi everyone. In the previous lecture, we have simulated a microstrip patch antenna. We have shown you the S11 results. Now, if we are interested in the gain of this antenna design, then we need to go and add the gain results. We will go to the simulation. We will select the field monitor, and here we have a list of monitors available. For example, I am interested at 2.4 gigahertz, so I will write 2.4 gigahertz. Then I will write far field RCS and then apply. After that, if I am interested in the furthermore result like E field, I will check this and I will apply it. So if you are interested in the field H field and surface current, check this and apply it. So the H field and surface current will be added in the results. If you are interested in the power loss density SAR, or if you are interested in some other results like the current density, so you can add it as well. Just click on apply and the result will be added in the field monitor here. So I will click on OK. After adding all these parameters, we will go to home, we will start the simulation, and the simulation will start again. After the simulation get complete, whatever results we have opted, they will be added in the results section. So the simulation will take some time. Now the simulation has completed. As we can see that we have obtained the results. Now in order to check the gain of this antenna, we will go to the 2D and 3D results, and you can see that E field, H field, surface current and current density are here. All the results have been added here. So in the far field, you can see that the far field cuts, far field F 2.4, all of them have been added here. So I will click on this and you can see that the far field results have been added. So in order to check the gain of this antenna, we can just check out from here. We can click on the gain and you can see that the gain is 2.944 dB. We can also check the realized gain, which is the 2.594 dB, and you can see that we have radiation efficiency and total efficiency here. And we can also see that we have the frequency, which is 2.4 gigahertz here. We can also see from this color palette, we can see that how much is the gain of this antenna. In order to see the antenna structure within this far field gain, we will right click on here and we will select the show structure. Then we will right click again, structure transparency and far field transparency. As you can see that antenna structure is in the center of this field. So we can, after rotating, we can see that this is our antenna structure, and we can see that its radiation pattern is in the direction of z-axis. We can also see the gain of this antenna within the 2D field, 2D as a 2D plot. So for that, we will just go and click on this 2D option. And you can see that we have a realized gain of 2.594 dB and we have the frequency of 2.4 gigahertz. We can also check this result in the Cartesian coordinate. We will click on S and you can see that this is the gain of our antenna design, and you can see that the frequency is 2.4 gigahertz, but the main lobe magnitude is 2.59 and the main lobe direction is 0.0 degree. We can also see the polar plot of this antenna design. So we will go to the option far field and we will click on the polar. So when we click on the polar, we can see the polar plot of our design. And this is a polar plot of our design. As we can see that we have the main lobe of at 0 degree with the lobe magnitude 2.59 and the frequency is 2.4 gigahertz. Since we have designed an antenna which is not accurately operating at 2.5 gigahertz, but my main aim was to teach you that how you can design an antenna. These are the dimensions of the strip, pitch, substrate, thickness and everything was just random. Main aim was just to teach you that how you can design microstrip patch antenna. So for this design we can also see the electric field line. So we will click on this option in the E field, and you can see that this is the electric field. We can animate this field. We can see that the electric field is like just within a time span of time this electric field is being shown. We can increase the thickness of this animation. We can also see the H field, which is the magnetic field, and you can see that this is our magnetic field. We can again change this slider by moving towards the plus or minus axis. We can zoom it, and you can see that this is the magnetic field or the H field of our design. Now if we want to see the current density of this design, we can also see the current density of our design. So what we will do is we will go to this option within the 2D 3D result. This is surface current density, and you can see that from the feed point the current is moving, and the antenna is resonating at 2.4 gigahertz. So the most of the electric field current density is on the patch. You can see that the current density is above the patch or of the microstrip patch antenna. So we can also change it to the streamlines, and you can see these are the streamlines of the electric current density. We can also change it into bubbles. So whatever results you like, you can show it or display it as an animation. So there are different type of results which could be animated in the CST Studio. So you can show it any type of result. We are interested in the arrows, so we have selected the arrows result. So here in this result we can see that this result has some gaps, like the current density is not at some strip lines. Like here we have some gaps, so we can introduce slots within the patch somewhere so that this current distribution could be made uniform. So we can also see for this antenna more different results, like VSWR, which is the voltage standing wave ratio. We have already in the first lecture discussed it. This is the Z matrix, Y matrix, and we can see some other results as well, like the balance. So these are all the different results of after the simulation that we have obtained for our design. So thank you.